Ah, işte
Hello.
bu.
Yeah.
Which will be represented by Hassan Huliyev. Hassan, over to you and good luck.
In fact, it's going to be represented by me, Ikram, but yeah.
It's fine, Ikram, go on.
All right. So does everyone see the slide that I pulled up?
Yes, absolutely.
Yeah. All right. So hello, everyone. My name is Ikram Gabib, and I'm a computer scientist at AzAstro, a startup that focuses on doing research on the cutting-edge domain of aerospace engineering. So one of the problems that we're trying to address is that in the EU, for example, the greenhouse gas emissions from aviation have actually increased by approximately 87% from 1990 to 2006. This eventually leads to an increase, in fact, a considerable increase in the levels of aluminum oxide, the carbon dioxide, hydrogen chloride, and other hazardous gases that could be harmful to our health. As you might know, light pollution is also one of the other major problems in the aerospace engineering industry. For example, the researchers that were working on taking the first image of the black hole in our galaxy have actually reported that one of the main and significant obstacles that they've encountered has been the light pollution, and it actually delayed their research for quite a bit. The space pollution that emerges from the accumulation of the remnants of satellites that have actually exhausted themselves is another main issue that may lead eventually to our inability to launch rockets and satellites into the space by the year 2040. So that's another problem that we're trying to address here at AzAstro. Our startup plans to decrease the greenhouse emission levels by utilizing different alternative energy sources, along with using GPS technologies and machine learning algorithms for different purposes, such as effective lookup of landing times and locations. We've done some market research, and it actually turns out that the main customers are going to be different businesses and that focus on developing and manufacturing aerospace technologies, such as AzAstro-nun, Tubitak, Rakuten, and Roscosmos. These are some of them. So here is one of our rockets that we're planning to develop. It's how the final version of its prototype is going to look like. So we're going to be using the N2900 engine. It's also going to have an avionics section that's going to contain different kinds of sensors, such as GPS, gyroscope, barometer, accelerometer, and etc. We're going to need the sensors to actually collect data that we're going to be using in our supervised and unsupervised learning algorithms, and also in some deep learning algorithms as well. Here are our team members at AzAstro. Here are some statistics and data on the engine that we're going to be using in our prototype. So here's our competitive advantage. The majority of other companies' rockets, some of the examples are Rocket Lab and Blue Origin in the aerospace industry. They're emitting excessive amounts of CO2 and other hazardous gases while being launched, which may result in serious threats to human health. AzAstro aims to use AI in order to optimize the levels of greenhouse gas emissions in our atmosphere. Here's also some statistics on the levels of emitted carbon dioxide coming from the rocket industries. We've also done some evaluation of our product design, and it turns out that the one prototype is going to approximately cost us circa $3,600, and we've also evaluated. We also figured that the market value of the prototype is potentially going to rise up to $4,750. Here is also some data over here on the materials that we're using and their costs. Thanks for watching.
Thank you, Ikram, for your exciting presentation. And now I'd like to invite our panel of juries on stage for the Q&A session. As a gentle reminder, the Q&A session will last only 5 minutes. Our organizers will be posting reminder messages in the chat as we approach the end of 5 minutes allocated. So please be on the lookout for that. Jury members, you may begin with your questions.
Thank you for presentation. It's quite interesting presentation. The Falcon, the Tesla's Falcon. Now you know very most guys coming in this hot talking and offer another solutions which could in future compare with these solutions. The first question is that AI you are going to use instead of traditional fuel. What is it and how we are going to burn?
So to address your question, and thanks by the way for it. By AI, we actually mean artificial intelligence. We're still going to be using the same fuel which is used by other rocket and aerospace engineering companies and industries in the industry, but the artificial intelligence algorithms that we're going to be using are trying to optimize the level. They're trying to optimize how we use that fuel, in fact. So we're still using the same fuel, but we're optimizing how we're using it. That's the main thing we're trying to address.
Hey there, Ikram. How advanced are you in your fundraising strategy? It's obviously a vertical industry that's quite high cost to enter. So what's your fundraising strategy look like at the moment?
Great question. Thanks. So right now we're actually participating in several competitions, the TechStart competitions especially in Turkey, and we're already almost done with our prototype. We do have the engine that we actually invested into with our own funds to participate in those competitions, and we're expecting to raise funds from those competitions, as they do give generous amounts of funds for different rocket and aerospace industry oriented startups especially. So we're targeting on those competitions first so that we could raise some funds from there, and then we're going to be investing those funds into to actually develop our project further. That's our goal.
Okay, and can you tell me just a little bit more about your go-to-market strategy? How are you planning to acquire customers?
So first of all, we're actually trying to so here's the main thing that we're trying to sell. I think that's one of the major points that I have to deliver, is that we're not actually trying to sell the prototype per se. We're actually trying to sell the algorithms that we're using. It's just the prototype is a nice way to demonstrate and prove that the algorithm in fact works. And they're way easier to sell than the actual rocket prototypes, as people might know. So the procedure of selling those algorithms to different rocket space in the aerospace industries is actually way easier, and it can be done. There are some examples, such as the Blue Origin startup company that actually was going on the same path, but what we have that they do not have are these AI algorithms that we're planning to implement. So that's our competitive advantage, if I have to mention it.
Thanks, Ikram.
Yeah.
Ikram, thank you very much. This is an interesting idea and innovative idea, actually. The question is, have you done any laboratory tests to see the percentage of, optimizing the gas and emissions using artificial intelligence?
Yeah, as I shown earlier on the slides, on one of them, in fact, we're going to be using the N2900 engine for our prototype, and we've actually been using it to test our machine learning algorithms. And in fact, we've been using the supervised learning for that, and we're planning to use the clustering for the unsupervised learning in the future. So right now, yeah, we do have some tests. We're testing how the machine learning algorithm can actually optimize the thrust of N2900 engine, and it does in fact give us promising results. So the machine learning can actually, the supervised learning algorithm can take data that we give it as an input from different sensors here on Earth, and that's how we test how that algorithm can adapt the thrust of the engine. And we've actually done that. Yeah.
Can you tell us about the team that you envision to work on this program? Like the expected,
Yeah. Great question. The team is, in fact, one of the most important things in this kind of business, because a lot of engineers who actually specialize in rocket and aerospace engineering have to work on these kind of projects, and we do have some of those engineers. So we have computer engineer working on this. Me as a computer scientist, I'm developing the machine learning algorithms. That's what I specialize in. And so, I also specialize in the software development. We also have people who are specializing in electrical engineering as well. Yeah.
Let's summarize. Time is over now.
Yeah, thanks.
Thank you, Ikram.